This lesson is on nonlinear systems, and if you think back to when you learned this in Algebra 1 or Math 1, linear systems were things that you did substitution or elimination or solve by graphing with. Today we're just going to focus on substitution. You could do substitution or solve by graphing with these, but we're going to focus on substitution. With these, they don't have to be functions because obviously they're nonlinear, and so we might get into some really weird looking things. You can have more than one answer that has the same x value because of that. So we don't have to pass the vertical line test. You might have an x value that has two different y values. Things that you need to keep in mind: when you take a square root, when you're solving and you take a square root, you need both the positive and the negative answers. If you get something that makes sense, like 4 equals 4 or 11 equals 11, something like that, your solution is all real numbers. In other words, they're on top of each other everywhere. If you get something that doesn't make sense, like 7 equals 0 or 5 equals 3, that means there's no solution, and those graphs actually are not crossing. So this one means the graphs are on top of each other, they're basically the same graph, and this one means that they don't touch at all. Okay, so here's our first example. We have two parabolas, and like I said, we're going to use substitution. And since this is already solved for y, I don't have to do any work to begin with. I'm going to take this x squared and plug it in for that y. So that's going to give me x squared equals 8 minus x squared. And then I go about solving that. And so I'm going to add the x squared to both sides and get 2x squared equals 8. I'm going to divide both sides by 2. X squared is going to be 4. And then this is one of those cases where I'm going to take the square root. And so when I think of the square root of 4, so I'm square rooting both sides. When I think of the square root of 4, I need to think of positive 2 and negative 2. I get both answers. That means these graphs cross each other in two places. These are the x values. And so right now, what I know is they cross at 2 something and at negative 2 something, and I'm going to find those y values as well. So to get the y values, I can plug into either equation. I'm going to use the first one just because it's easier. So if y equals x squared and I plug in 2, I get 4. So that means the y value of this first point is 4. And then if I plug in the negative 2 squared is also 4, because the negative times a negative is a positive, and so I have the point negative 2, 4. This is technically my answer, the 2 points where those cross. And in this case, you can actually visualize what's going on. You guys know what the graph of y equals x squared should look like, which is your basic parabola. 8 minus x squared is a parabola that's been flipped and moved up 8. So it's something like this. And what we just found are the points where they're crossing. They're crossing at 2, 4 and negative 2, 4. So we just found that algebraically. But again, if you graph those in your calculator, you would see that graphically. But I want you to be able to focus on using substitution to do these. Okay, in number 2, we also have two parabolas, and they're both face up, but they could actually touch or cross each other. So we're going to, again, use substitution, and this one, again, is nice because the y is already by itself. And so if y equals this, I can plug all of this into y. So I have 2x squared plus 3x plus 4 equal to x squared plus 2x plus 3. Now, this is a quadratic, so I'm going to have to do a little bit to work on it. I need it equal to 0. So I'm going to start by subtracting x squared and subtracting 2x and subtracting 3 so that I get 0 on this side. Now, if you need to do those each in an individual step, then please do so. But if you want to save paper, do them all at once. So I get x squared plus x plus 1. this does not factor, so I need to do the quadratic formula. So x equals negative b, and our b is a 1, plus or minus the square root of b squared minus 4ac all over 2a. And again, I'm doing this because it did not factor. So I get negative 1 plus or minus the square root of 1 minus 4 all over 2. And then if I come up here and simplify, I have x equals negative 1 plus or minus the square root of negative 3 over 2. Now, that square root of negative 3, you may remember from a previous math class, is an I. And so that's an imaginary number. And if you get one of those, that's also like a no solution. That means these graphs don't cross. They don't intersect anywhere. And I should probably use the mathematical word intersect. And so that is another situation where you would get a no solution. Okay, if you have I's as your answer, that's definitely no solution. Okay, example 3, we're out of the parabolas because we have x squared and y squared, and this is going to be something that you learn about the shape of later on in this class. But this is actually an ellipse, and the x equals y, or excuse me, x times y equals 4. If you divide by the x, you'll notice that that is just a transformation of your toolbox function y equals 1 over x. So these could cross in several places. Alright, this is a little bit different because I don't have a y or an x by itself. And the easiest one I feel like to work with is the bottom one. So I'm going to solve for x. I'm going to divide by y. So my x is going to be 4 over y. And you can do either one. I could have gotten the y by itself as well. But I'm going to take this and I'm going to plug it in for x in the other equation. And I chose the x because the y had to be multiplied by 2 as well. So there was less to do with the x. But you could have solved this equation for y and plugged in for y. Either way, you should get an answer in the end that's the same. So I'm going to plug that in, and I'm going to have 4 over y squared plus 2y squared equals 12. And then I square the 4 and square the y, so I have 16 over y squared. And then I have a situation where I need to get rid of the fraction. And the way to get rid of the fraction is by multiplying everything by that denominator, y squared. So y squared, y squared, y squared times everything. It'll cancel with the denominator in that first thing just like we wanted it to. But here you'll get 2y squared times y squared, so that will be 2y to the 4th. And then that should equal 12y squared. I'm going to again get this equal to 0, so I'm going to subtract that 12y squared, and I'm going to put things in order over on the left. So I'm going to start with my 2y to the 4th. I have subtracted the 12y squared. The 16 is still there, and I have it equal to 0. Now this will actually factor. If you'll notice, that power goes from 4 to 2 to nothing, so it almost factors like a trinomial. But I do notice that everything has a 2 in it, so I can take a GCF out first. So 2y to the 4th minus 6y squared plus 8 equals 0. And then when I factor it into the 2 parentheses like I would a trinomial, instead of just a y, because this is y to the 4th, I'm going to have y squared here. And then I just have to think about what multiplies to give me 8 and adds to give me negative 6. And that's going to be a negative 4 and a negative 2. Okay, I'm still trying to solve, so I'm going to come up here with my work and have 2, this y squared minus, I can actually set each thing equal to 0. So 2 equal to 0, y squared minus 4 equal to 0, and y squared minus 2 equal to 0. Obviously 2 doesn't equal to 0, so you can trash that. That just meant there was a vertical stretch there. Y squared minus 4, I can add the 4, and then when I take the square root, I have to remember to do the positive and the negative. So square root both sides, square root of y squared is y, square root of 4 is positive 2 and negative 2. And then over here I get y squared equals 2, and again, when I square root both sides, I need to think of the positive square root and the negative square root. I'm not going to get the decimals for these, I'm just going to leave them as square roots. What does this mean? This means I have 4 points. I know the y value at 4 different points. These graphs are intersecting at 4 different points. So we're going to kind of make a little chart and finish this out. Okay, we went through all of that and we found 4 y values. Y equals negative 2, y equals positive 2, y equals the negative square root of 2, and y equals the positive square root of 2. And I'm going to do work with each one of those to find out the x value that goes with them. I can plug into either one of my original functions. I'm going to plug into this x, y equals 4 because obviously it's a lot less complicated than the top one. So if x, y equals 4, then I'm saying here x times negative 2 equals 4. If I divide by negative 2, I get a negative 2. That means one of the points where they cross is negative 2, negative 2. Then I move to the next one. If my y value is 2, I have x times 2 equals 4. Divide, I get x equals 2. So my second point where they cross is 2, 2. My third one, I have x times the negative square root of 2 equals 4. When I divide here, I have to think almost like I do on my unit circle. I have to rationalize. So I have to multiply by the square root of 2 over the square root of 2. So x is going to equal negative 4 square roots of 2 over 2, and then that's going to reduce to negative 2 square roots of 2. So the point where they cross is negative 2 square roots of 2, negative square root of 2. And then my last one, x times the positive square root of 2 equals 4. I can divide. Again, I get 4 over the square root of 2, which is the exact same thing I had over here, except over here it was negative. So I know that my answer is going to end up to be 2 square roots of 2 because it's the same exact math steps except for the negative. And so the point where they cross here is 2 square roots of 2 square root of 2. So these 4 points are my answer. That is the 4 places this graph crosses. And I believe that that first one is an ellipse, and that second one, like I said, is a 1 over x graph, so it probably looks something like this. You don't have to know that at this point. You'll be learning that later on this semester, but I just wanted to show you how you could cross in 4 places. Okay, for our last example, you may recognize the first one as a circle with a center at 0, 0 and a radius of 10. And the second one is a line. So just because I have a line here doesn't mean, you know, this is a bad thing. It's still a nonlinear system because it's crossing with a circle. And so we're going to work on it. Obviously, nothing is solved for here. I'm going to have to solve for something. I'm going to pick the bottom equation because it's just the easier one to work with. And I'm going to add x. So I'm going to get the y by itself and say that it is x plus 2. If I add x to the other side. I'm going to take that x plus 2 and plug it in for y in the other equation. Make sure you're plugging into the opposite equation than what you just worked on. So if I do that, I get x squared plus x plus 2 squared equals 100. This means I have to FOIL, so I'm going to write that twice. So I'm going to get x squared plus, I'll get x squared plus 2x plus 2x plus 4, still equal to 100. That's going to give me 2x squared plus 4x plus 4. And because this is now quadratic, I realize I need it to be equal to 0. So I'm going to subtract the 100 and have a minus 96 over here. Again, I notice everything is divisible by 2, so if I take that out, it's going to make factoring it a lot easier. And it's going to leave me with x squared plus 2x minus 48 inside. And that, I just have to think, what's going to multiply to give me 48, or negative 48, and add to give me 2. And that's an 8, a positive 8, and a negative 6, because those will multiply to give me a negative, but they'll add to give me a positive 2. And then, just like always, I'm going to set each piece equal to 0. So 2 equal to 0, x plus 8 equal to 0, and x minus 6 equal to 0. Obviously 2 does not equal 0, so I toss that. Subtract, I get x equals negative 8. Add, I get x equals 6. So I know it's going to cross in 2 places, and these are the x values. I need to get the y values. I can plug into either equation. I can actually even plug into this equation over here because it's just a version of this one, and I think that's what I'm going to do. So for x equals negative 8, the y value will be negative 8 plus 2, so negative 6. That means that this point is negative 8, negative 6. Then if I plug in 6, y equals 6 plus 2, I get 8. And then that point will be 6, 8. And so these are the 2 points where this line crosses this circle. And I know the answers seem kind of similar, just kind of backwards and change signs and things like that. You'll get that when graphs are somewhat symmetric. So don't stress over that and be very careful with your signs. That concludes this lesson.